And today's target is to give you the introduction, fundamental principle of counting, and conception of factorials. This class is going to help students preparing for boards and competitive exams. It is going to be an excellent class full of information and tricks to solve problems, which will not only boost your preparation but also develops your problem solving skills. Those who are new to my channel, if you really like my teaching, press the subscribe button along with the bell icon so that you get all the notifications about all such informative and useful videos which I upload in this channel. Don't forget to like and share the tutorial with your friends and make their preparation better, which is at no cost. Comment me if you have any query or suggestions to improve your preparation. So let's get started. So you have seen that in the thumbnail I have given the name of this chapter as Permutation and Combination. To be very precise, the name of this chapter is Combinatorics. Combinatorics actually deals with two things. One is called permutation and another one is called combination. So there are two things in Combinatorics chapter. What are those? One is called your permutation and another one is called your combination. What is permutation? Whenever there is a question of arrangement, it's a question of permutation. But if the question is of selection or grouping, then it is called combination. Is it clear? So permutation is when arrangement of objects are involved. Hence, here order is important. Let us say there are two people. Now, two people will be seated in two chairs, and let us say we have named the chairs like A and B. Now, if the first chair is occupied by the first person and the second chair is occupied by the second person, it is an arrangement. Now, if they interchange their place, that is, the second person is coming to chair A and the first person is going to chair B, so it's another arrangement. That exactly what I'm talking about, the order. So in arrangement, order is important. So in permutation, AB and BA, these are two different arrangements. But in combination, whenever it's a question of grouping or selection, it's a case of combination, and here order is not important. What I want to say is, suppose there is a group where there are 5 boys. Now I want to make a group of my own where there will be 3 boys. Now whether that boy is 1, 2 or 3 or 2, 1, 3, does it matter to me? No. So in this case, the order does not matter. So it's a question of combination. Always remember in this way, whenever order matters, it's permutation. Whenever order does not matter, it is combination. Because in the question, nobody is going to tell you this problem is from permutation and this problem is from combination. Nobody is going to tell you. You have to identify which sum is your permutation and which sum is your combination. Is it clear? Okay. So what we have learned, combinatorics is the mathematics of counting and arranging. Of course, most people know how to count, but combinatorics applies mathematical operations to count quantities that are too large to be counted in the conventional way. Is it clear? Mainly combinatorics are specially used in computer science, right? So combinatorics are divided into two groups. Actually, combinatorics deal with two things. One is called permutation, another one is called combination. Permutation is all about arrangement and combination is all about grouping or selection, right? So now let us come for the next part, which is fundamental principle of counting. What do you mean by fundamental principle of counting? Suppose we have to complete a work. This complete work is divided into two jobs. Let us say one job is J1 and the other job is J2. So one work is divided into two jobs, job 1 and job 2. Now, if that work is completed by job 1 and job 2, what I'm saying is this work will be completed when you complete job 1 and job 2. So when this and is coming in between, fundamental principle of counting states that you have to multiply the number of ways of doing job 1 and the number of ways of doing job 2 to complete that work. Let us say J1 can be done in m ways and J2 can be done, job 2 can be done in n ways. Now if the work is to be completed by completing job 1 and job 2, so the total number of ways will be m into n. Is it clear? So whenever they are saying that you have to complete the work by doing job 1 and job 2, the moment this and comes in between, so we should be very sure that they are talking about multiplication. But if I say that the work can be done either by J1 job, if you complete J1 job, the work will be completed, or if you do job J2, the work will be completed. So in between we are getting or. So to complete the work, either you do job 1 or you do job 2 and the work will be completed. If this is the scenario, you look at very carefully what you are getting. You are getting or in between. So when or is coming in between, it means that we have to go for addition. We have to go for addition. That is, the work will be done in how many different ways? M ways plus n ways. So when the the work is done by job 1 and job 2, the total number of ways of completing the work is m into n ways. But when the work is completed either by job 1 or by job 2, the total number of ways of completing the job is m plus n. Is it clear? So this is all about your fundamental principle of counting. So now we will directly move for problems based on fundamental principle of counting. See this question. The question is, there are 3 routes to travel from, let us say this is my Mumbai. there are 3 routes to travel from Mumbai to Kanpur. Let us say this is my Kanpur. So there are 3 ways, there are 3 routes to reach at Kanpur from Mumbai. Okay. Then from Kanpur to Kharagpur, there are 4 routes. From Kanpur to Kharagpur, there are 4 routes. Right? And from Kharagpur to Kolkata, there are 5 routes. 1, 2, 3, 4, and 5 routes. Now the question is what? In how many different ways a man can travel? Travel means you can use the routes from Mumbai to Kolkata via Kanpur and Kharagpur. Now try to understand. See, nobody has said that this is the question of permutation or combination. Nobody has said. You have to understand what actually they are asking for and whether the question involves multiplication or addition. See, the complete work is what? When the person reaches from Mumbai to Kolkata, that is the complete circle. When the person reaches from Mumbai to Kolkata, that is the complete circle, but via Kanpur and Kharagpur. Now, from Mumbai to Kanpur, there are 3 ways. So, a person can choose one way at a time. So, there are 3 ways for the person to reach Kanpur from Mumbai because there are 3 routes in between. Now I have reached Kanpur. From Kanpur to Kharagpur, we are having 4 routes. The person from Kanpur, if he wants to reach at Kharagpur, he will choose either one way or one route among these 4 routes given. So there are 4 ways to reach from Kanpur to Kharagpur. Now the person has reached Kharagpur by taking any one route. From Kharagpur to Kolkata, we have 5 routes. Now the person, if he wants to reach to Kolkata, he has to choose any one route among these 5 routes. So there are 5 ways to reach Kolkata from Kharagpur. Now the question comes, what is the total number of routes available for the person to reach Kolkata from Mumbai via Kanpur and Kharagpur. Is it clear? Now, my question to you is, will I add these 3 to get the total number of ways? Or I have to go for multiplication to get the total number of ways? That's a big question. Now you ask yourself, the complete work is what? A person starts his journey from Mumbai. First he reaches Kanpur, then he reaches to Kharagpur, then he reaches to Kolkata. So from Mumbai to Kanpur, in how many ways you can reach there? In 3 ways. Now, have you reached Kolkata? No. Your job is still pending. Now from Kanpur you are reaching to Kharagpur. In how many ways? In 4 ways. Have you reached Kolkata? No. I have to do another job. That is, I have to choose a route from Kharagpur to Kolkata where there are 5 routes available. So I have to choose only one. So there are 5 ways. So now I will reach Kolkata via any of these routes, 5 routes. So the total number of ways will be, total number of routes available will be, first from Mumbai to Kanpur, and from Kanpur to Kharagpur, and from Kharagpur to Kolkata. Are you getting? You cannot say or. If I say from Mumbai to Kanpur or from Kanpur to Kharagpur, does it make any sense? I have to reach Kolkata. So how will I reach Kolkata? From Mumbai to Kanpur, and from Kanpur to Kharagpur, and from Kharagpur to Kolkata. So you are saying and in between. So definitely from the fundamental principle of counting, I have to go for multiplication. Therefore, total number of ways will be 3 into 4 into 5, which gives us 12 into 5, that is 60 ways. Have you understood? This is a very basic problem, but this problem is an ideal problem to understand the fundamental principle of counting. Is it clear? Let's move for the next problem. There are 17 IITs and 20 NITs. Listen it very carefully. There are 17 IITs and there are 20 NITs. In how many ways a student cleared both JEE Main and advanced exams can select an institute? Now, a student who has cleared both JEE Main and advanced, he has the option to choose either IIT or he can choose NITs. So now, the student who has cleared both exams can select IIT in 17 ways, and he can select NITs in 20 ways. Now the question comes, how many total ways are there that student can select IIT or NIT? Because a person cannot get admitted in IIT and NIT both. So either he will select an IIT or he will go for NIT. So in between, or is coming. And from the fundamental principle of counting, whenever or comes in between, we should go for addition. Therefore, total number of ways of selecting IIT or NIT for a student who has cleared both JEE Main and advanced exams is 17 plus 20, that is 37 ways. So that student has 37 ways of selecting either IIT or NIT, who has cleared both JEE Main and advanced, because he has the provision, he has the permission to choose any of the IITs or NITs, right? So in this question, or will come, that is why I have added, not multiplied. Is it clear to all of you? Okay, let's move for the next problem. Now see this question. There are 17 IITs and let each IIT has 11 branches. There are 17 IITs and we are having 11 branches. Now the question is, in how many ways an IIT topper means he is allowed to select any IIT, and in that IIT he is allowed to select any branch. So the question is, in how many different ways the IIT topper can select the IIT and the branch? Now try to understand. The IIT topper can select any of these IITs. He cannot select both the IITs at a time. Can you think in that way, that I will study in IIT Bombay as well as I will study in IIT Kanpur? It's not possible. So you have to select one IIT at a time. So the IIT topper will select one IIT from these 17 available IITs. So that can be done in 17 ways. So 17 ways says what? It is the number of ways in which the topper can select the IIT. Now, game is not over. I mean, the work is not done completely, because now I have to select which branch I want to go. I have selected one IIT. Suppose I have chosen IIT Bombay. Now I have to select, since I'm an IIT topper, so I have that, all the branches are available to me. So now I have to select which branch I can go for. In this case, there are 11 branches. So I have the option of choosing any one of these 11 branches in 11 ways. So the topper can select the IIT and the branch, and is coming in between. Total number of ways will be 17 into 11, that is 187 ways. Is it clear to all? See, actually I have taken very preliminary sum, but these sums actually helps us to understand the conception of fundamental principle of counting. Because until and unless you are crystal clear about where I have to multiply and where I have to add, it will create problem every time, I'm telling you. So at the very basic stage, you must be clear about this conception. And that is why I'm taking those sums to make you understand, to make the conception clear to you. Okay? Let me take another problem. So in this question, they have said that in a cinema hall, there are 8 doors by which anyone can enter and leave. See the first one. The first question states in how many different ways a person can enter and exit by a different door. Now, in how many different ways a person can enter the cinema hall? There are 8 doors. So that person has 8 ways to enter the cinema hall. Now he enters the cinema hall. He has to exit by a different door. Now he enters the cinema hall by taking one door at a time, because I cannot enter the cinema hall by taking 2 doors at a time. No, not possible. So I have to choose only one door, which can be done in 8 ways. Now I have to exit by a different door. So the door that I have already used to enter the cinema hall, I cannot use that door to exit. Therefore, there are 7 left doors through which I can come out. So the total number of ways when a person can enter and exit by a different door is 8 into 7, that is 56 ways are there. Tell me yes or no. Why I have done and? Because I will enter the cinema hall by one door and I have to exit the cinema hall by a different door. So I can enter the hall in 8 different ways because I have 8 doors. Now the door I have used to enter the cinema hall, I cannot come out through that door. So I had to select the remaining 7 doors to exit from that cinema hall. So enter and exit can be done in 8 into 7 ways, that is 56 ways. Is it clear? Now see the second question. In how many different ways the person can enter and leave by any door? So I can enter the cinema hall in 8 ways. Now I have no restriction. I can come out from the cinema hall through that door which I have used to enter the cinema hall. So again, for exit, I have 8 ways to come out. Therefore, the total number of ways of entering and leaving by any door in the cinema hall is 64 ways. Have you understood the problem? Very simple problem, but very nice problem to have the fundamental clear for your counting principle. Okay, so let's move for the next problem. See this question. It has been stated that starting from any of the m's, the word madam can be spelled by moving either up, down, left or right to an adjacent letter. You see, madam is basically a palindromic word. What do you mean by palindromic word? In a palindromic word, if you spell it from the beginning or from the last, you are going to get the same word back. This kind of word is what called your palindromic word. So in this case, your madam is a palindromic word. Now what is the question? The question is you have to spell the word madam starting from M, and you can go either left, right, down or up. That is, you cannot jump any grid because they have already said that your movement will be either left, right, up or down in the adjacent letter. So you cannot jump any grid. This is number one condition. And number two condition, you cannot go diagonally also because you have to go in the adjacent grid, right? Now the second part what they have said is the same letter may be used twice in each spell. What do you mean by that? Suppose if I want to spell madam and if we start from M I can come to this D and from D I can retrace back to M. So you will see that this A or this M has been used twice. This is accepted. Now the question comes, how many different ways are there to spell the word madam? Now what to do? What I will do here is, I will divide this complete job, that is to spell madam, I will divide this job into two halves. What are those? Job 1 is to reach from M to D. And your job 2 is to reach from D to M again to form the word madam, right? Okay, so let us first consider in how many different ways your J1 can be accomplished. That is, in how many different ways if we start with M, we can reach to D. If I consider this M, and to reach D, we have only one way. If we consider this M, again we are having one way, this M, one way, and this M, again one way. So there are four ways to reach at D from M if we consider the extreme M's here. Now, if we consider this M, then to reach at D, either I can choose this way or I can choose this way. So for every M this M, we are having two ways to reach at D. Now this position M we are having in 4 places. So to reach at D from these 4 places, there are total 8 ways. And to reach at D from these extreme 4 M's, there are 4 ways. So your job 1 can be accomplished in 4 plus 8, that is 12 ways. Is it clear to all? So what we have done in job 1, we have simply reached D from the M. Is it clear? Now the work is not over, because to make the work over, you have to again come back to M. Then only the word madam will be formed. Till now, only MAD has been formed. Okay, so now we will consider how many number of ways are there to accomplish J2. That is to reach
M from D, how many number of ways are there? Okay, let me just erase this. Now look it carefully. We are now at this D. At this position we are now. Now, in how many different ways you can reach to M? Let us just consider that. First is we can go by this path, or we can go by this path, or this, or this. Okay? So there are 4 ways to reach from this D to M, these extreme M's. Now we will consider from this D in how many different ways we can reach at this M. There are 2 ways. Either I can go by this way or I can go by this way. So to reach at this M from this D, there are 2 ways. Similarly, there are 4 such positions of M. So from this D, if you want to reach at these 4 positions, there will be how many number of ways? There will be total 8 different ways. So total number of ways obtained to reach from D to M is again 12 ways. Am I correct or not? So now your job 1 can be done in 12 ways. Your job 2 can be done in 12 ways. Now to spell the word madam, you have to do job 1 and job 2, right? Then only you can spell the word madam. So the total number of ways to spell the word madam will be 12 into 12. That is 144 ways. Is this clear to all? Absolutely. What I have done, I have simply divided the total work into 2 jobs. Because we have to spell madam. First job is that I want to reach from any of these M given to us to D. And that can be accomplished in 12 ways. Now from D I have to get back to M. There are again 12 ways to reaching at M again. So total number of ways to spell the word madam is 12 into 12. That is 144. I hope why I have multiplied, it's very much clear to you, right? Okay, so answer is 144. Let's move for the next problem. How many numbers between 99 and 1000, both excluding, can be formed such that every digit is either 4 or 5? Now, numbers between 99 and 1000, both excluding, means they are talking about 3-digit number. Any number between 99 and 1000, both excluded, will be a 3-digit number. Now, every digit is either 4 or 5. Listen it very carefully. Every digit is either 4 or 5. That means this place can be filled in 2 different ways. Either 4 or 5 will come. This place can be filled with again 2 different ways, because either 4 or 5 will come, and same thing is going to happen in this place. So total number of ways of such such numbers between 99 and 1000, both excluded, will be 2 cube. That is 8 such numbers are there, in which either every digit is either a 4 or 5, right? Let us see number 2. No digit is repeated. We have to form 3-digit number. No digit is repeated. So this place can be filled in 9 different ways. Why it is so? Because this number cannot start with 0. If it starts with 0, it no more remains a 3-digit number, it will become a 2-digit number. So this place, the 100 place, will be filled in 9 different ways. Now, no digit is repeated. So 1 digit has been written over here. That digit cannot be used here. in the 10th place I cannot use the digit which I have used in the 100th place. Therefore, this place can be filled again in 9 different ways. Why? Because now your 0 can come in this place. That is why the 10th place can be filled in 9 different ways. Why 1 is subtracted? I mean, why I have not considered 1 digit? Because that has already been used in 100th place and no digits are repeated. That's the question. So now 2 digits has been consumed in this 2 place. So the 3rd place, that is the unit place, can be filled in 8 different ways. So total number of digits, 3-digit number that can be formed is 9 into 9 into 8, where no digits are repeated. So total numbers will be 648. Is it clear to all? Okay, what is the 3rd point? It states that the digit in tens place is 8. Means in this 3-digit number, they have already said that your 8 has occupied this place. Now they have not said anything whether the digits will be repeated or not. So what by default I will take, the digits can be repeated. Now the digit is always in the tens place. Which digit? 8. So this place can be filled in 9 different ways. Again, 0 cannot come. Because if 0 comes in the 100th place, it will no more remains a 3-digit number, it will become a 2-digit number. That is why 0 cannot come, and that is why 9 ways are there to fill the 100th place. Now what about the unit place? Again, there will be 10 such ways. Because here your 0 can come, your 8 can also come, doesn't matter. What is the condition in this problem? The problem is your 8 is always in the 10th place. Now whether that 8 is coming in the unit digit or 100th place, it doesn't matter to me. My 8 is in the 10th place. That's all. That's the condition given in the question. So total number of such digits that can be formed, I mean the number can be formed is 90. Okay? In which your 8 is always in the 10th place. See the 4th question. The digit 8 does not appear at any place. Simple. Your digit 8 will not appear in any of this 3-digit place. So this place now, the 100th place can be filled in 8 different ways. Ask me why? Because this place cannot be filled with 0. This place cannot be filled with 8. Because 8 is not used anywhere in these numbers. So the 10th place can be filled in. Why with 9 different ways? Because any digit can come other than 8. Again, the unit place can also be filled in 9 different ways. Because again, your 8 cannot come. So total number of ways where 8 will never come is, that is again 648. Is it clear to all of you? So total number of numbers that can be formed where 8 does not appear at any place is 648. Now the next question, the last one is, at least one of the digits is 8. It means what? At least one of the digits is 8. That is, in this 3-digit number, either in one place there is 8, or in 2 places there are 8, or in 3 places there are 8. At least one, matlab kam se kam ek. So 1 8, at least 1 8 must come. So what I'm doing here is, I'm first saying that how many numbers are there, how many numbers are there where there is no restriction. How many 3-digit numbers can be formed without any restriction? This place can be filled in 9 ways. This place 10 ways. This place 10 ways. So total 900 numbers can be formed. So there are 900 ways to form the number. Now what I am saying is, I am saying that no number will be formed which will have 8. And we have already calculated that there are 648 ways are there where there will be no 8. So if I subtract from the total number of ways, what we are getting? We are getting 252 ways of forming the numbers in which at least one 8 will occur. Think in a very precise way. You see, whatever 3-digit numbers you are forming, there are only 4 conditions. Either those digits will not contain any 8, or it will contain 1 8, or it will contain 2 8s, or it will contain 3 8s. Other than that, can you imagine any number of 3-digit? No. Right? So what I have done, I have simply subtracted all those numbers which does not have 8 in their numbers. The digit 8 does not appear in their numbers. So that is 648 we have simply calculated in the previous part. So now without restriction, how many number of numbers we will form? It is 900 that we have seen. Now if I subtract 648 from 900, what we are getting? We are actually getting the numbers which will contain either 1 8, means a digit will be 1 8, or 2 digits will be 8, or 3 digits will be 8. That is, at least one digit is 8. Clear? So the answer in this case will be 252. I hope this sum is very clear to all of you. Okay, let's move for the next problem. Say this question. In how many ways Virat Kohli can invite 6 friends for Anushka's birthday? Anushka is Virat Kohli's wife. We all know that. Now, if Virat has 3 servants to carry the cards, there are 6 friends of Virat Kohli. Now, they will be invited for this Anushka's birthday party. Now, Virat has only 3 servants to carry those cards. In how many different ways all these 6 friends of Virat will be invited, and the invitation card has been served by these 3 servants? Okay, now one servant can carry all those 6 cards. So one servant can go and invite all the 6 friends. So in how many different ways this can be done? See, this friend, this friend can get the invitation card from any of these 3 servants. Tell me yes or no. This particular friend will get its invitation card from any of these 3 servants. So this person can be invited in 3 different ways. Tell me yes or no. Either the first servant will go and invite, or the second servant, or the third servant. So there are 3 ways in which these servants can carry the card for this friend, for the first friend. Same thing with the second friend. This friend can get the invitation card from any of these 3 servants. So again, there are 3 ways that this servant can carry that card to this second friend. Same thing with the third friend, same thing with the fourth friend, same thing with the fifth friend, and same thing with the 6th friend. So total number of ways in which all these 6 friends can be invited for Anushka's birthday is nothing but 3 to the power 6. Is this problem clear? Virat has 6 friends. For his wife's birthday, he is going to invite all those 6 friends, but he is having only 3 servants. And these 3 servants is going to carry their invitation card. In how many different ways the friends can be invited? First friend can get its invitation card from either of these 3 servants. So there are 3 ways that the first friend can be invited. The second friend can be invited again in 3 ways. Why? Because any of these 3 servants can invite the second friend. Same thing with the third, fourth, fifth and sixth. So total number of ways in which all these 6 friends will be invited in Anushka's birthday by Virat Kohli's servants in 3 to the power 6 different ways. Is it clear? Therefore, your answer will be 3 to the power 6 gives us 729. Hence, there are 729 ways in which all these 6 friends will be invited by these 3 servants of Virat. Is it clear? Okay, let's move for the next problem. Say this question. Find the number of subsets of set having n elements. A set has n elements. Let us say A1, A2, A3 and this goes on. There are n elements. Now the question is how many number of subsets you can form from these n elements. Now to form a subset, if I consider the first element, you are having 2 choices. Either this element will come in that subset or it will not. So there are 2 options for the first element to be selected in the subset. 2 ways. Same thing with the second element. Either it can come in your subset or it will not. Again, there are 2 ways. Again, for the third one, you are having 2 ways. And the same thing goes for an element also. So there will be total number of subsets formed is 2 to the power n. Now you can ask me one question, sir. It may so happen that you are always saying that the first element can be chosen or not. Suppose if I choose that element is not selected in the subset. The same thing happens with the second element, third, fourth and the nth element. That is, in your subset, no element is coming. Then is it forming a subset? Yes. Because that subset will be a null set. And null set is always a subset of the original set. So when no elements are coming, which is already included in 2 to the power n, that is also a subset of the given set. Therefore, a set having n elements, the total number of subsets that can be formed is 2 to the power n. Is it clear? Okay, let's move for the next problem. So in this question they have said find the number of distinct rational numbers x such that x is lying between 0 and 1. It means what? That your x is basically a fraction which is of the form x is p over q and p, q are taking values from this set 1, 2, 3, 4, 5, 6. We have to find out how many number of distinct numbers x are there for which your x is lying between 0 and 1. That is, x is a fraction. Distinct fractions you have to find out. So naturally we have to consider cases here. Okay, so let's see. If I say that p is 1, then your q can take the value 1, 2, 3, 4, 5, 6. No, I cannot take 1 because if I take 1, it no more remains a fraction. Therefore, the x will take the value what? Half, 1/3, 1/4, 1/5 and 1/6. Am I correct? Now, if P is 2, your Q will start taking the value from 3, 4, 5 and 6. Therefore, your X will be 2/3, 2 by 4, that gives us half, 2 by 5 and 2 by 6, which gives us 1/3. Let me consider the third case when P is taking the value 3. Then your Q can take the value 4, 5 and 6. So in that case, your X is coming to 3 by 4, 3 by 5 and 3 by 6. 3 by 6 is basically half. Now let us take P is 4. In that case, your Q can take the value 5 and 6. So your X will become 4/5, 4/6. That gives us 2/3. Now when P takes the value 5, your Q can take only one value, which is 6. And your X will become 5/6. And P cannot take the value 6, because in that case your Q will take the value 6. Then X will become 1, which is actually not falling in the region 0, 1. Therefore, how many number of distinct X so formed? Check it now. Here is half. Half is common. Half is common. So I cannot take half 3 times. I will take half only 1 time, because all X are distinct. 1/3 we are having here, 1/3 we are having here also, and no more 1/3. So 1/3 will come once. 1/4 here, no more 1/4. So 1/4 is a distinct number. 1/5, again 1/5 is not coming anywhere. 1/5 is distinct. And 1/6, again, which is not common in any X. So they are all distinct X. Now we are having 2/3. 2/3 is there. 2/3 is here also. So 1 time 2/3 I will take. Then we are having 2/5. So 2/5 is again distinct. 3/4. 3/4 we are not getting anywhere. So it's 3/4 here. 3/5. 4/5 and 5/6, they are all distinct. So 3/5, 4/5, 5/6, they are all distinct. So how many number of distinct X are to be formed? These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So 11 such distinct X are possible which satisfies the given condition. Is it clear? Hence our answer is 11 in this problem. So have you understood this problem? Pretty simple sum. Here naturally we have to consider the cases to find out how many distinct X are possible. Because if you don't consider cases, if you simply do it arbitrarily, then there will be some number X which will be repeated and which you will count twice or thrice. In that case, your answer will become wrong. So that is why I have considered all those cases here and we got our final answer. So let's move for the next problem. In this question, they have said a regular polygon of 10 sides is constructed. Triangles are formed joining the vertices of the polygon. Find the number of triangles formed if two sides of the triangle coincide with the sides of the polygon. Very interesting sum. Let me do one thing. There are 10 sides. So let me just draw. Let me consider 5 sides. Okay. Then we will expand the problem in 10 sides. So how many sides are there? 1, 2, 3, 4, 5. Okay. Let us take 6 sides. Now it is basically a 6-sided polygon. Now we will actually do the question by taking 6 sides, and whatever conclusion we will come, we will simply expand it for 10 sides polygon. Is it clear? Okay, now the first question is that if 2 sides of the triangle coincide with the sides of the polygon. In this is a hexagon having 6 sides. Now you have to form triangles in such a way that 2 sides of the polygon coincides with the 2 sides of the triangle. So if I consider this side and this side, we are going to have this one triangle. Then if we consider this side and this side, again we are having one triangle. If we consider this and this, we are having another. Then again we have another triangle in which the 2 sides of the polygon coincides with the 2 sides of the triangle. Again we are having this triangle. Again we are having this triangle. That's it. So how many number of triangles such formed? 1, 2, 3, 4, 5 and 6, I think. This is 1, this is 2, 3, 4, 5 and then 6. Correct? So there will be 6 such triangles when we join the points of the vertices of the polygon to form a triangle. But in this case, 2 sides of the triangle coincides with the 2 sides of the polygon. Hence there are 6 triangles. Now there were 6 sides. We have taken 6-sided polygon and we got the triangles which can be formed, which is having 2 sides coincide with the 2 sides of the polygon, is 6. So in our question, the polygon is of 10 sides. The polygon is of 10 sides. So naturally, if 2 sides of the triangle coincides with the 2 sides of the polygon, then the total number of such triangles formed will be 10. Is it clear to all? Okay. So let us see. So the first answer for this one will be 10. 10 such triangles will be formed. Let us consider number 2. What is that? If only one side of the triangle coincide with the side of the polygon. Again, we will take hexagon. Now what is the question? If one side of the triangle coincide with the side of the polygon. Now in this question they are saying that you form a triangle, but only one side of exactly one side of the triangle will coincide with the side of the polygon. So let us consider this side. Let me consider this side. Now if I consider this side, then I cannot join these 2 points with this point. Let me change the color of the pen. We cannot join this point with these 2 points. Why? Because if I join it, it will become a triangle but whose 2 sides will coincide with the sides of the polygon. That I don't want. I want exactly one side will coincide with the side of the polygon. So by any means, when you are choosing this side, you cannot choose this point or this point to form the triangle. So naturally we will join the point either this one or this one with these 2 points to get a triangle whose one side will coincide with the side of the polygon. So actually, when we are considering this side, we are actually we are having 6 points. But from these 6 points, we should eliminate 4 points. Why we will eliminate 4 points? Because neither of these 4 points can be used to form the triangle. Otherwise, our condition will be violated. So we are left with only 2 points, by virtue of which you can form that triangle which fulfills our condition. So when 6 points are there and we are considering one side, we are taking the rest 2 points which can be joined with the extremities of this line to get that triangle whose one side will coincide with the side of the polygon. So in same case, if it is a 10-sided polygon, if I consider only one side of the polygon, you are going to have 6 points left outside which can be joined with the extremities of this edge, so that we are going to have a triangle whose one side, exactly one side, will coincide with the side of the triangle. Yes or no? So there are 6 points available only by choosing one side. Now, for a 6-sided polygon, we are having 6 such sides. So for 6 such sides, the total number of triangles that will be formed, which is following our condition, will be 6 into 2, that is 12 such triangles. Tell me yes or no. So in our problem, we are having 10 sides. For each side, we are forming 6 such triangles. So for 10 sides, we are going to form 60 such triangles whose one side, exactly one side, will coincide with the side of the polygon. Is it clear? Therefore, the answer for the second one is 60. Is it clear? So now let's move for the next conception in this lecture, which is your factorial notation. So what do we mean by factorial notation? It's like if I say factorial 5, it means it is basically 5 into 4 into 3 into 2 into 1. That is, whatever factorial is given to you, it means starting from that digit, you come down till 1, reducing 1 every time, and you multiply all those digits, gives us the value of factorial of that number. So if I say factorial 7, it means 7 into 6 into 5 into 4 into 3 into 2 into 1. Now if I want that after 6, I'm not going to write anymore. So you simply write that thing as factorial 5. Now factorial of any whole number is defined. That is, if I ask you what is the factorial of 3 by 2, it is not defined. If I say what it will be, let us say minus of 3 by 2, or if we say minus of 2 factorial, it does not have any meaning. So factorial means it's always the whole number. We always find out the factorial of any whole number. No negative integers, no fraction, no negative fraction, factorial is defined. Now, if I say factorial n, it means what? It is basically n into n minus 1 factorial. So from here we can write n minus 1 factorial is factorial n divided by n. Now in place of n, if I put 1, so in the left hand side we are getting factorial 0, and in the right hand side we are getting factorial 1 by 1, which gives us 1. Therefore, factorial 0 is 1. We have to remember this result. Is it clear to all? Have you understood what actually factorial means? It is simply the product of all the digits starting from that digit till 1. And factorial 0 is always 1. Negative integer, fraction, negative fraction, factorial is not defined. Clear? So let's take a problem now. In this question we have been given n plus 2 factorial is 60 into n minus 1 factorial. So what I'm doing is I'm expanding this n plus 2 factorial like n plus 2, n plus 1, n, and now I will stop. So I will give a factorial sign there, which is equals to 60 into n minus 1 factorial. Have you understood how I have written n plus 2 factorial in this way? What I have done, I have simply reduced, every time I'm reducing 1 from the previous term and I'm giving a multiplication sign in between. So whenever I want to stop, I will simply give a factorial sign and I will stop there. That's exactly what I have done here. So now from both sides, I'm cancelling n minus 1 factorial. So we are left with we are left with n plus 1 into n plus 2, which is your 60. Now, how to find out the value of n? In this case, maximum students try to factorize it. Don't go for it because it will consume a lot of time. Now, here 3 factors are there. Now, if there are 7 factors or 8 factors, how I will multiply and to get the values of n? Not possible for me. So that is why what I will do, I will simply write this 60 in this way. How we can write 60? It is 5 into 4 into 3. Yes or no? It can be written as 3 into 4 into 5. So now if I compare both sides simply by inspection, you can say that your n is going to take the value 3. That's it. Is it clear? Okay, let's move for the next problem. Answer is 3. The question is prove that r into factorial r, and we have taken a sigma over there, is equals to n plus 1 factorial minus 1. Okay, so we have to deal with this sigma thing. What is given to us? R into r factorial. R into r factorial. This also I can write in this way. R into, I'm writing r as r plus 1 minus 1 into factorial r. So that gives us r plus 1 into r factorial minus r factorial. So from here we are getting r plus 1 into r factorial can be written as r plus 1 factorial minus r factorial. Am I correct? Now we are taking sigma on both sides. This is same as your telescopic method, which we have learned in sequence and series. So if I take sigma where r starts from 1 till n, so actually what we are getting, if I put r equals to 1, factorial 2 minus factorial 1, if I put r is 2, factorial 3 minus factorial 2, then if I put r equals to 3, we are getting factorial 4 minus factorial 3, and this thing goes on. And the last, when I put n in place of r, we are getting n plus 1 factorial minus n factorial. Now, if I add those terms, because there is sigma, we have to add. If we add, we will find that this term will get cancelled. So we will be left with n plus 1 factorial minus 1 factorial. Therefore, sigma r into r factorial gives us n plus 1 factorial minus 1. Hence proved. Is it clear to all? Have you understood how I am operating on the factorial sign? Okay, so let's move for the next problem. The question is find the remainder when factorial r, where r starts from 1 till n, is divided by 15. That is what they are saying is, what will be the remainder when this whole term, it goes till n terms, is divided by 15. What will be the remainder? Now, if you observe carefully, you will find that starting from factorial 5 till factorial n, in all those factorials, we are always having two factors. Other factors will be there, but two factors are common here. What are those? One is 3 and another one is 5. In factorial 5, it is basically, you see, your 3 and 5 is there. In factorial 6, it is same as your factorial 5, only a term 6 will come. Again, we are having 5 and 3. So 5 into 3, that is 15, is common from factorial 5 till factorial n. Am I correct or not? That is, when factorial 5, from factorial 5, if I go on dividing by 15, it will be completely divisible because every term consists of 15 in its product. Isn't it so? So every term from factorial 5 onwards, if you divide by 15, the remainder will be 0. So the remainder of this expression which is given to us, that is from 1 till n, from 5 till n your remainder is 0. So actual remainder will come when these 4 terms are divided by 15. Whatever remainder we will get from these 4 terms when we divide it by 15 is the remainder of the given expression. Is it clear to all of you? So what is factorial 1? It's 1. Factorial 2 is 2. Factorial 3 is 3 into 2, that is 6. Factorial 4 is 4 into 3 into 2 into 1, that gives us 24. So if you add up, we are getting 33. 1 plus 2 plus 6 plus 24 gives us 33. So the remainder of the given expression in our problem, when divided by 15, the remainder will be generated from this 33. Now when this 33 is divided by 15, we can see that remainder is 3. Therefore, when the expression which is given to us is divided by 15, the remainder will be nothing but 3. Have you understood this problem? Because every term from 5 factorial onwards, every term it has 15 as a factor. Therefore, when we divide those terms by 15, the remainder is 0. So the remainder will actually come from the number which we got by adding factorial 1, factorial 2, factorial 3 and factorial 4, which is actually 33. Now when it is divided by 15, the remainder is 3. Therefore, when the given expression is divided by 15, the remainder will be 3 only. Is it clear? Let's move for the next problem. See this question. If the unit digit of factorial A, factorial B plus factorial C is 9, then what will be the value of factorial A into factorial B into factorial C? Now, when the unit digit of these 3 numbers when added gives us 9, if any number you choose more than 3, the unit place will never become equals to 9. If I take factorial 4, any of these values, either A or B or C, if it is factorial 4, the last digit will come to 4 only. It will never gives us, when you add the 3 terms, it will never give us the unit digit as 9. Yes or no? Because if I take factorial 5, your factorial 5 gives us 120, that is 5 into 4 into 3 into 2 into 1. So the unit digit is coming to 0. Any number which is more than 5 or more than 5, the unit digit will be always 0. Therefore, the unit digit will 9. It will come from 1 factorial, 2 factorial, 3 factorial or 4 factorial. Tell me yes or no. The unit digit will be decided by adding any 3 of these 4 numbers. And we can see that this is 1, this is 2, this is 6 and this is 24. Under any circumstances, if you take factorial 4 into your consideration, that is either any one value a, b, c becomes 4, then the sum of factorial a plus factorial b plus factorial c will never give us, the unit digit will never be equals to 9. Therefore, the only possibility that the unit digit will be 9 when we add factorial a plus factorial b plus factorial c, when a is 1, b is 2 and c is 3. Because factorial 1 plus factorial 2 plus factorial 3, that gives us 9. Or you can take one thing, any one of this value you can take as 0, b as 2, c as 3. Then also you are getting factorial 0 plus factorial 2 plus factorial 3, which is again coming to what? 9 only. So these are the only 2 cases where the unit digit will be equals to 9. There is no other values of a, b, c. If you add those 3, you will get the unit digit as 9. Not possible. So what is the required value of our problem? It is factorial a into factorial b into factorial c. So either it will be factorial 0 into factorial 2 into factorial 3, or it will be factorial 1 into factorial 2 into factorial 3. So from the first one we are getting 1 into 2 into 6, that is 12. In the second case also we are getting 12. Therefore the answer for this product is 12 only. Yes or no? Have you understood this sum? Is it clear to all of you? Okay, so let's take the next problem. See this question. The question is, show that 1 factorial plus 2 factorial plus 3 factorial, and if this thing goes on, 4 factorial, 5 factorial, and this thing goes on till n factorial, it is saying to prove that this term will never give us a perfect square if your n is more than 3. That is, if you take your n as 4, 5, 6, whatever, you are never going to get a perfect square. That is the thing which is required to prove. So what I will do here, please look it very carefully. Factorial 1 is 1, factorial 2 is 2, factorial 3 is 6. And factorial 4 is coming to what? 24. Factorial 5 is coming to what? 120. And this thing goes on. From factorial 5 onwards, the last digit will be always 0. Now, if I add these 4 terms, we are going to have 33. Now, if I choose any number n which is more than 3, that is, if we start from factorial 4, factorial 5 and so on, and if you add it up, the last digit will be guaranteed 3. Tell me yes or no. If I add, let us say factorial 1 plus factorial 2 plus factorial 3 plus factorial 4 plus factorial 5 and so on till say factorial 100. Even if you add all those terms, the last term, the last digit will be guaranteed equals to 3. Yes or no? Because from factorial 5 onwards, the last digit is 0. So the last digit is decided from which one? From factorial 1 plus factorial 2 plus factorial 3 plus factorial 4. From there we are getting the last digit as 3. Therefore, any number which is 4 and onwards, 5, 6, 7 and so on, if you take any of those numbers and if you add their factorials, the last digit is going to be 3. Yes or no? And most interesting thing is that you will never find square of any number which ends with 3. Which ends with 3. Therefore, any number which is greater than 3, the last digit is going to be 3, and square of any number cannot end with the digit 3. So what we have proved? We have proved that if you add all those natural numbers factorial, if you sum it up, if n is greater than 3, it is not possible to get a number which is a perfect square. Till 3, it's a perfect square because factorial 1 is 1, factorial 2 is 2, and factorial 3 is 6. Now, if you add this, you are going to get 9, which is a perfect square. 3 square is 9. But if it is more than 3, and if you add, you will never get a number which is a perfect square. Why? Because if you add, the last digit of those terms is going to be 3. And square of any number does not end with 3. Okay? Is it clear? Okay. So now let's move for a next new conception, which is called exponent of prime p in factorial n. So what do you mean by exponent of prime p in factorial n? First, you must remember one thing, that any natural number can always be factorized and it can be expressed as the product of primes. Any natural number you choose, you can express that natural numbers as product of primes. So factorial n, it is also a natural number, maybe a very big natural number, but it's a natural number. So naturally, if it's a natural number, we can express this natural number as a product of primes. So now I want to find out what will be the exponent of any prime in that particular factorial. Let us say factorial n. So it's a natural number. You are having product of primes. If you factorize it, you are going to you can express it as a product of primes. Now any prime I choose, and if I ask you what will be its exponent of that prime, let us say factorial 100. If I ask you what will be, because it's a natural number, you can express it as a product of primes. So 11 is a prime number, it will come in that product. So what will be the exponent of 11? Or what will be the exponent of other prime, say 13 or 17 or 19 or 23, whatever, or 29. So that we have to find out. We will definitely use a formula, but before that we will understand actually how this formula is coming. So back to the computer screen. Let me take an example of factorial 500. Now if I ask you what will be the exponent of the prime 5? In factorial 500, it's a natural number, so it can be expressed as a product of prime. 5 is a prime, so it will have some exponent. We want to find out what is that exponent of 5. So how to find it out? Don't see the formula right now, because we will derive this formula step by step. So first of all, you see your 500 actually can be written as 500 factorial can be written as what? 500 factorial can be written as 1 into 2 into 3 into 4 into 5. This thing goes on. Some 10 will come, then 11. This thing will go. Again 15 will come, then 16. And this thing will go on. Again 25 will come. 26, 30. This thing goes on. I'm just writing it. Why? Because I want to make you understand how actually the thing is working. So it's now it will come 40, then at some place it will come 50, and this thing will go on. Then somewhere it will come 100, it will come 125, and this thing goes on. Isn't it so? This thing goes on. Okay? Till we reach 500. Now I want to simply find out how many digits are there which are simply the multiple of 5. How many digits are there in factorial 500 which are multiple of 5? What are those numbers? It can be 5, it can be 10, it can be 15, 20, 25, 30, and this thing goes on like 50, then 75, then 100, and all these things. Okay? So how many number of multiple of 5s are there? I want to find out. How I will find out? Simply by dividing 500 by 5. So you will say that there will be 100 such multiples of 5 in factorial 500. Is it clear to all of you or not? So in everywhere in the multiple of 5, you are getting 1 5 from each number. From 5 you are getting 1 5, from 10 you are getting 1 5, from 15 you are getting 1 5. So it will be what? 100 such 5s there. Means multiple of 5. Okay? Now, everywhere, if you look it carefully, till this it's okay to you? Now see, there are also digits like 25, 50, 100, 125, 150, and this thing goes on. 175, 200, goes on till 500. All those numbers, they are not only having only 1 5, they are having more than 1 5. Here whatever we have considered that there will be 100 multiples of 5, there we are getting only 1 5. Other than these numbers, from these numbers you are not getting 1 5. Then how many number of 5s you are getting? Look it carefully. 25 is basically 5 square. So you are getting 2 5s. From 50 you are getting 25 into 2. That is 5 square again. Yes or no? Again from 100 what you are getting? 25 into 4. Again you are getting 2 5s. So how many number of such 5s are there? All you will do is, you will simply divide 500 by 25. Am I not correct? So in this case, you are going to have 20. So there are 20 such numbers from which you are getting 2 5s. Already 1 5 you have considered when we have considered the multiple of 5 only. So these 20 numbers will have 2 5s in their number. But already you have considered 1 5 before. So 1 5 each, we will consider 1 5 into our consideration. So there will be 20 such 5s there. Again, there is another interesting thing in these numbers. there will be numbers like 125, 250, 375, 500, in which you are actually getting 3 5s. This is 5 cube. This is 5 cube into 2. This is 5 cube into 3. This is 5 cube into 4. So from these 4 numbers, you are actually getting 3 5s, from which you have already considered 1 5 when we have considered multiple of 5. We have considered another 5 when we have considered the multiple of 25. Yes or no? So we are left with 1 5 in each of these numbers, which we have not considered yet. So how many such numbers are there? Though we can see that there are 4 such numbers, but how many such numbers are there if we do it mathematically? We will write that if 500 is divided by 125, we are getting 4. That means we are having 4 such numbers in which we are going to get 3 5s from each and every number. Am I correct or not? Okay, so now there will be no such number in this factorial 500 where you are going to have 4 power of 5, because 5 to the power 4 gives us 625. 625 is not a number which is involved in 500 factorial. So we have to stop here. Therefore, we will write that the exponent of 5 will be 100 plus 20 plus 4. That is 5 to the power 124. Is it clear or not? So what will be the exponent of 5 in factorial 500? It will be 100 plus 20 plus 4. So it gives us 124. So have you understood this? Before remembering the formula, you should know how we are actually getting it. Then it will be easier for us to remember. So what we have done, in factorial 500, we want to find out what is the exponent of 5. So we have to check individual numbers and we will see how many number of 5s are involved in all these 500 numbers. So there first I saw how many numbers are multiple of 5. We got that thing as 100. How we got? Simply by 500 divided by 5. Now we see that in those numbers which are multiple of 5, not only 1 5 is involved, like in 25, in 50, in 75, in 100, not only 1 5 is involved, there are 2 5s involved in it. But we have already considered 1 5 when we have considered the multiple of 5 only. So in every digit which is a multiple of 25, we have not considered 1 power of 5. Are you getting my point? There are actually 2 5s in 25. 1 5 you have already considered when you have considered the multiple of 5. But you have not considered 2 5s. So the another 5, how I will get? I will simply see how many number of multiples are there. Multiples of 25 are there in 500. So in that, so when we have divided by 25, what we got? We got 20 such numbers are there. In 20 such numbers, there will be not only 1 5, there will be 2 5s, in which 1 5 has already been considered in 100. We got 100, multiples of 5 are 100. So in that multiple of 5, we have already considered 1 power, but we have not considered another power of those kind of numbers, 25, 50, 75 and all. So now we got how many number of multiples of 25 are there in these numbers? We saw that there are 20 such numbers. So 20 such 115 will come out. That is 20 more 5 will come out. Is it clear? So before we got 100 5s and now we got 20 more 5s. Okay. Going through the numbers, we saw that there are certain numbers which are 125, 250, 375, 500. These are the numbers in which not only 2 5s are involved, 3 5s are involved in it. In 125, what you will write? You will write 5 cube. What is 250? 125 into 2. 125 means 5 cube. So 3 5s are involved in such numbers. How many such numbers are there? 500 divided by 125. That gives us 4. So 4 such numbers are there, which involves, in each number it involves 3 5s. Out of which 2 5s we have already considered. So we have not considered 4 more 5s from these 4 numbers. So that has to be considered to find out the ultimate exponent of 5. Are you getting my point? Therefore, the total number of terms, the exponent of 5 will be 100 plus 24. 100 plus 20 plus 4. That gives us 124. And that will be the exponent of 5. Is it clear to all? Now let's come to the computer screen and let me describe the formula. You don't have to remember all these things. This I have all done to make you understand. So now I'm giving you a ready-made formula by virtue of which you can find out exponent of any prime in factorial n. What is that? It states that the exponent of the prime p of any factorial is basically greatest integer function of n divided by p plus n divided by p square. What is p? P is that prime. N divided by p cube, and this thing will go on. This is your greatest integer function. Okay? Until and unless you are getting this thing to 0, the value of this box or greatest integer function is coming to 0, we will go on continuing this. Okay, so whatever result we will get is basically the exponent of the prime p. Now see, in our case, the question was, what is the exponent of 5? What was the exponent of 5 in factorial 500? So what I will do? 500 divided by 5, 500 divided by 5 square, 500 divided by 5 cube, then again 500 divided by 5 to the power 4, and this thing goes on. So from the first one we are getting 100, from the second one we are getting 20, and from the third one we are getting 4. But from fourth one onwards we are all getting 0, right? Therefore the exponent of 5 in factorial 500 will be nothing but 124. That's exactly what the answer we got here. Is this clear to everyone? If you have not understood the logic, I will suggest you to please rewind this video after the class and you can go through it slowly. You will understand what actually I am telling. And if you don't even remember this method, then also you can solve this kind of problem. To find out the exponent of any prime in factorial n simply by remembering the formula that I have given to you. Is it clear? Now let's move for some problems. See this question. Find the exponent of 11 in factorial 100. That is, you want to find out what is E11 of factorial 100. So what I will do? I will simply do greatest integer function 100 by 11, 100 by 11 square, and I will stop here. In this case we are going to have 11 divided by 100 divided by 11, that gives us 9 point something. So greatest integer function of that will give us 9. And from here onwards, 11 square is 121. 100 divided by 121 gives us a fraction. So the greatest integer function of that part will become 0. So all other rest elements, The numbers will give us 0. So we are left with only 9. So it implies what? It implies that your factorial 100, it's a natural number. So it can be expressed as a product of primes. There will be a prime 11 and the exponent of that prime 11 is nothing but 9. Have you understood this question? Okay. See the next question. Proves that factorial 33 is divisible by 2 to the power 19. Let us just first do the first part. We have to prove that factorial 33 is divided by 2 to the power 19. So what I will do? I will simply find out what is the exponent of 2 in factorial 33. So how to find it out? Greatest integer function 33 divided by 2. 2 square, 2 cube, 2 to the power 4, 2 to the power 5. No need to write anything else. Achha, let me just write one more term. This thing goes on. So what you are getting here, we are basically getting 16 because it is 16.5. Greatest integer function of 16.5 will give us only 16. This is given us 8. This will give us 4. This is 2. And this is 1. And then 0, 0, 0. Okay? So what will be the exponent of 2 in factorial 33? It will be 28, 30, 31. Am I correct? So in factorial 33, we are having 2 to the power 31. Am I correct or not? So it can be easily seen, since factorial 33 is having 2 to the power 31, so definitely it is divided by 2 to the power 19. No question about it. Is it clear to all of you? Yes or no? Hence, we have proved that factorial 33 is clearly divisible by 2 to the power 19. Now, what is the second part? The second part says, what is the largest integer n such that factorial 33 is divisible by 3 to the power n? So the question actually demands you have to find out the exponent of 3 in factorial 33. That's it. That will be the large, because your n cannot exceed that number, right? So the largest value of n, which is divided, which can be divided by factorial 33 is divided by 3 to the power that number, that is the largest number, which is nothing but the exponent of 3. Am I clear or not? So let us try to find out what will be the exponent of n here. So we want to find out what is the exponent of 3 in factorial 33. Divided by 3, 33 divided by 3 square, 33 divided by 3 cube, 33 divided by 3 to the power 4. No need to write anything else. Here we are getting 18. Here we are getting 3. Here we are getting 1 and 0, 0, 0. Right? So 15. Therefore, your factorial 33, the exponent of the prime 3 is nothing but 15. Am I correct? So tell me, what is the largest integer n such that factorial 33 is divided by 3 to the power n? Your n is nothing but 15 in this case. Is this problem clear to you? Simple sum, simple. These are the sums which generally used to come in the state board engineering entrance exam. Maybe it can come in your JEE Mains also, but for West Bengal JEE or any other state level entrance examination, this kind of problems are very common. So you must practice those things. What we have done in the second part, we have been said that factorial 33 will be divided by 3 to the power n. What will be the largest value of n? That is, we have to find out what is the exponent of 3. And we got the exponent of 3 as 15. Therefore, the largest value of n is nothing but in our problem is 15 only. Is it clear to everyone? Absolutely? Okay, let's move for the next problem. Now in this question they have asked find the number of knots or ciphers at the end of 125 factorial. Now what do you mean by knots or ciphers? This is basically the number of zeros that are there at the end of 125 factorial. That's it. So knots and ciphers are nothing but number of zeros at the end of the number. This is also called trailing zeros. So three things are having the same meaning. Ciphers, knots and trailing zeros. They are all same. It is the total number of zeros that are present in a number at the end. Clear? So now the question comes, how to find out the number of knots or ciphers at the end of 125 factorial? Now to know the number of ciphers, you must know in 125 factorial, what is the exponent of 10? Because if we know the exponent of 10, we can easily say how many number of ciphers or knots are there at the end of that number. If I say 10 cube into 8, you will easily say, sir, there are 3 trailing zeros or knots at the end of this number. Right? But the question comes again, how to find out how many number of 10s are there in 125 factorial. In 125 factorial, if we go for prime factorization, we will have all the prime numbers. Though we will have the exponent, but exponent of whom? Of prime numbers. But you will not get 10. So until and unless you have 10, you cannot say how many number of trailing or cipher will be there at the end of that number. So what to do? One thing I can use, the common logic is that your 10 is written as 2 into 5. So if we know what is the exponent of 2 and what is the exponent of 5, because 2 and 5 are both prime numbers. Now we can find out what is the exponent of 2 and what is the exponent of 5 in 125 factorial. So the moment you know this, you can easily predict what will be the exponent of 10. And which in turn will tell us how many number of ciphers are there at the end of this number. That's it. So let us try to find out how many what will be the exponent of 2 in 125 factorial. So what I will do? Greatest integer function 125 divided by 2, 125 divided by 2 square, 125 divided by 2 cube, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, and so on. So we are getting, when 125 divided by 2, that gives us 62.5, and the greatest integer function will take 62 plus 31 plus 15 plus 7 plus 3 plus 1. And after that, all zeros will come, right? Therefore, the exponent of 2 in 125 factorial will be 119. Okay? So now let us try to find out what will be the exponent of 5 in 125 factorial. So that gives us 125 divided by 5, 125 divided by 5 square, 125 divided by 5 cube, and so on. So we are getting basically 25, 5, and then 1. And after that, all zeros will come. Is it clear? So we are getting basically 31. Therefore, the exponent of 2 in factorial 125 is 2 to the power 119, and that of 5 is 31. Therefore, the exponent of 10 will give us 31, because here we have to take the lowest value of the exponent. Among 2 and 5, the lowest value of the exponent is 31, which is actually the exponent of 5. So we have taken that and we have seen that it's not 10, it's 5. Therefore, we are getting the exponent of 10 as 31. Hence, there will be 31 ciphers at the end of 125 factorial. Have you understood the problem? There they have asked to find out the number of ciphers. To know the number of ciphers, we must know what is the exponent of 10. But there is no chance of finding out what is the exponent of 10 in prime factorization of any number. So in 125 factorial, there will be no 10. So we have to forcefully bring 10. What logic I have applied? 10 is nothing but 2 into 5. So we got what is the exponent of 2 and what is the exponent of 5. The moment we have that in our hand, as we got in this case, that exponent of 2 is 2 and exponent of 5 is 31. Therefore, we are sure that the exponent of 10 in this case will be nothing but 31. Tell me yes or no. Therefore, there will be 31 ciphers at the end of 125 factorial. Now, one very important thing, if you observe carefully, you will find that if we go for prime factorization, then always remember that the factors, as we move from smaller to the higher one, I mean if we move from the smaller prime to the higher prime, the exponents will keep on reducing. Exponents will keep on reducing. The exponent of 2 will be much higher than the exponent of 3, will be much higher than the exponent of 5, will be much higher than the exponent of 7, and so on and so forth. So, in this question, it's a tips. You must remember this. What is the tips? The tips is that whenever they ask you, okay, how many number of ciphers will be at the end of some number whose factorial is given. So all you will do is, no need to find out what will be the exponent of 2. Because you know that the exponent of 2 will be much higher than the exponent of 5. So the moment you know what is the exponent of 5, that much will give us the answer what will be the exponent of 10, eventually what will be the number of ciphers at the end of that factorial. Isn't it so? So whenever trailing zeros or ciphers or knots are given in the question, always find out the exponent of 5. No need to find out the exponent of 2, because now this information is with us. that the exponent of 5 will be lesser than the exponent of 2. Hence, we will consider that lesser exponent. Hence, we will only find out the exponent of 5 in those cases. Right? Okay, let's move for the next problem. See this question. 15 factorial. This is all is given your prime factorization. And they have asked to find out those exponents, because the moment you have those exponents, you can find out this value. This value, finding out this value is nothing. So we have to find out the exponent only. So let us just find out what will be the exponent of 2 in factorial 15. So that gives us this gives us 7, 3, 1 and 0. So it's only 11, right? So this is actually your alpha. Am I correct? Let us find out what is the exponent of 3 in 15. So this is coming to 5. This is coming to 1 and again 0. So it is coming to 6, which is nothing but your beta. What is the exponent of 5? 15 over 5 plus 15 over 5 square. So that gives us, actually it will go on, but no need to write that because all will give us 0. So this is coming like 3 and this is coming like 0 and so on. So it is coming only 3, which is actually your gamma. What will be the exponent of 7 in factorial 15? So this is again coming to 2 plus 0, so on. So this is your 2 only. And 2 is nothing but your delta. Right? What is the exponent of 11 in factorial 15? So we are actually having 1, this is 0. So it's 1. Therefore, your theta is 1. Next, we have to find out what is the exponent of 13 in factorial 15. So we are having one plus 0 again. So it's only 1, and which is your 5. Have you understood this? Now, have you observed one thing here? Just now what I told you in the previous sum. That whenever we go for prime factorization, as we increase the, as we move from left to right in prime numbers, the exponents get decreasing. And exactly that is happening over here. Have you seen it? Please see this. What is the exponent of 2? It's 11. The exponent of 3 is 6. It has been reduced. Exponent of 5, 3. Again reduced. Exponent of 7, 2. Again reduced. Exponent of 11, it's 1. Again reduced. And so on. So every time when you go for prime factorization, and as we move from left to right, in the prime numbers, the exponent of that primes will start on decreasing. Is it clear? Okay. So what will be the answer now? We have been asked to find out this value. So we are basically having 3 into alpha, 4 into beta, 6 into, oh, I'm sorry, this is 2. Just 1 second. Minus 2 into gamma. Gamma is how much? Gamma is 3. Then 6 delta. Delta is 2. Theta. Theta is 1. And again phi is 1. Phi is 1. So we are actually having 33 minus 24 minus 6 plus 12 minus 5 plus 1. So actually we are having, from here we are getting actually 6, 9 minus 6, and from here we are getting actually 7 plus 1 is 8, right? So it's 9 plus 2, so the answer is 11. Is it clear? Is this clear to everyone? Absolutely. Okay, so now we have already learned how to find out the exponent of any prime in any factorial given to us, because any factorial can be expressed as a product of prime, and we know how to find out the exponents of those primes, right? Let me take another example. Say in this question they have said find the number of trailing zeros. Again, what is trailing zero? It is the ciphers or the noughts, that is the number of zeros present at the last of this number given, which is 5 to the power 10 factorial. So what I will do, to know what is the trailing zeros, what I told you right now, 5 to the power 10 is a natural number. So when it is, it is factorized in prime factorization, we are going to get the primes. And the exponent of the primes will go on decreasing as we go from left to right. Is it clear? So we have to know the trailing zeros, we have to know what is the exponent of 10. And for that, we will simply find out what is the exponent of 5. Isn't it so? Only the exponent of 5 will say how many number of zeros are there at the end, or the number of trailing zeros. Check it out. So what is the exponent of 5 in 5 to the power 10 factorial? Yes or no? This thing goes on till the last term will come like this, 5 to the power 10. Then it will be 5 to the power 10 divided by 5 to the power 11. Now I have to stop. So from here we are getting 5 to the power 9, 5 to the power 8, 5 to the power 7, so on. And the last term will give us 1. And the rest will be all zeros. So it is basically 1 plus 5 squared plus 5 cubed. It's 5 to the power 9. So it is, we can easily see that it is in GP. So what will be the sum of this? It will be nothing but, there are 10 terms and common ratio is 5. So it will be 5 to the power 10 minus 1 divided by 5 minus 1. That is 5 to the power 10 minus 1 divided by 4. So the number of trailing zeros, that is the number of zeros at the end of 5 to the power 10, will be nothing but 5 to the power 10 minus 1 divided by 4. And that's the answer. Is it clear to all of you? Have you understood this problem clearly? So now I hope you are comfortable enough to find out the number of trailing zeros or ciphers or noughts at the end of any factorial given to you. Am I correct? Can I be confident about you all people? Okay, let's go for the next problem. Now, in this question they have said find the exponent of 80 in 180 factorial. Have you seen the question? How will find out what is the exponent of 80? Big question. Big question. Because 80 is a composite number, it's not a prime number. So when 180 factorial is factorized, prime factorization, we will get the prime values. Prime digits we will get. So we will never ever get 80. So how to get the exponent of 80? This will be your homework. Please do comment me. What is the answer? What is the answer for this question? What will be the exponent of 80? You definitely write in the comment section, and I will definitely get back to you whether you are correct or not. Okay, so now we will learn a very new thing, very interesting thing, at the same time very basic thing. To know the thing that I'm going to discuss right after this small lesson. Okay, so check it. How to find the last two digits of numbers. This is a part of number theory, and finding out the last two digits of numbers are widely used in mathematics, especially in permutation and combination. In other chapters also, this method is used. So now we are going to learn how to find out the last two digits of numbers, in which we will deal with two very important numbers widely used in mathematics. One is 1024. What is the speciality of 1024? Because this number can be expressed as 2 to the power 10. Now if the exponent n is odd, then the last two digits of that number will be 24. And if n is even, the last two digits will be always 76. More interesting thing is that if I take 76 and if we raised its power to even or odd exponent, the last two digits will be always 76. Right? Now let us come for the second number, which is our 81. What will be the last two digits of 81 to the power some exponent? Whether it is even or odd doesn't matter. The method is, first you write down the unit digit when 8 is multiplied with n, and simply place 1 at the unit place to get the number which will be the last two digits of the given number 81 to the power the exponent n. Let me take an example. If I say 81 to the power 5, what will be the last two digits of this number? First you multiply 8 with 5, which is going to give us 40, and take the unit place digit, which is 0, and simply place 1 in the unit place of this number to get the last two digits of the number 81 to the power 5. Let me take another example. 81 to the power 37. First you multiply 37 with 8 and take the unit digit. So we are getting 296 when 8 is multiplied with 37. So take the unit place digit, which is 6, and simply give a 1 at the last. So you are going to get the last two digits of 81 to the power 37, which gives us 61. Is it clear? Now let us learn how to find the last two digit of numbers when two numbers multiplication is given. That is, when 37 is multiplied with 26, what will be the last two digits without doing the actual multiplication? So remember the method that I am teaching you. First you multiply 7 with 6, that gives us 42. Write the unit digit here and carry 4. Then you multiply 6 with 3. This is called crisscross multiplication. Multiply 6 with 3 and take the unit digit place. 6 3s are 18. I will take only 8. Then multiply 2 with 7. You are getting 14. But you take only 4. The unit place digit I will always take. Add this. You are getting 16. And simply place the unit digit that you got after adding, which is nothing but 6. Therefore, 62 will be the last two digits when 37 is multiplied with 26. You can check it with your calculator. Let me take another example. What will be the last two digits when 78 is multiplied with 37? Again, multiply 7 with 8. That is 56. Write 6 here, carry 5. Then you go for crisscross multiplication. 7 7s are 49. You will take the unit digit of this number, which is 9. Then you multiply 3 with 8, gives us 24. Take the unit digit of this number, which is 4, and add these three numbers. You are getting 18. And from here you will take the unit digit number, which is 8, and write it here to get the last two digit, which is 86, when 78 is multiplied with 37. Is it clear? Let me take another example. 57 multiplied with 79, what will be the last two digits? Again, multiply 9 with 7, that gives us 63. Write 3 here, carry 6. Then you go for crisscross multiplication. 9 5s are 45. Take the unit digit, that is 5. Then 7 7s are 49. So take the unit digit, which is 9, and add these three numbers. We are getting 20. So now write down the unit digit what we got in this case, which is 0. Write it here to get the last two digits, which is here your 03, when 57 is multiplied with 79. Is it clear to all? Now the question will arise, sir, if 3 digits are given and we have to find out the last two digits, then what to do? Let me take an example. 537 multiplied with 268. What will be the last two digits? I am giving you a very interesting fact that in this case you simply reject 5 and 2. That is, the 100th place digit are simply ignored in this sum. Now we are left with only 37 multiplied with 68. We have to find out the last two digits when 37 is multiplied with 68, and that will be eventually the last two digits when 537 is multiplied with 268. So let me just do it. 7 8s are 56. I will write 6 here, carry 5. Then crisscross multiplication. 8 3s are 24. Write down the unit digit here, which is 4. Then multiply 6 with 7. That gives us 42. So take the unit digit number, which is 2, and add these three numbers. We are getting 11. So take the unit digit, which is 1 here, and place it here to get the last two digits when 537 is multiplied with 268. In our case, we got the answer as 16. Is it clear? Let me take another example. What will be the last two digits when 854 is multiplied with 669? Again, simply ignore the 100th place digits, and you have only left with 54 multiplied with 69. The last two digits that we will get from here will be same as last two digits when 854 will be multiplied with 669. 9 fours are 36, write 6, carry 3. Then crisscross multiplication, 9 fives are 45, write 5 only. 6 fours are 24, write 4 only. And add this 3, we are getting 12. Therefore, the last two digits, when 854 is multiplied with 669, is 26. Is it clear to all? Now we will find the first non-zero digit of any factorial. How to do that? The first question will come, sir, what do you mean by first non-zero digit? Okay, let me take an example. Factorial 5 is written as 120, right? So the first non-zero digit here will be 2. If I take factorial 7, we are getting 5040. And the first non-zero digit is 4. I hope you have now understood what is the first non-zero digit. Let me take another example. Suppose some natural number is there whose factorial is, let us say, like this. Now if I ask you what is the first non-zero digit, your answer will be 7. Now I hope you have understood what is the first non-zero digit, right? Now let us take an example and let me try to elaborate the conception. Find the first non-zero digit in factorial 32. Now in this case, practically, it is not possible for us to multiply all the digits involved in factorial 32 to evaluate what will be the first non-zero digit. So definitely we have to develop a method by virtue of which we can easily, without not going for actual calculation, we can say what will be the first non-zero digit. And that is our task in this part of the lecture. 32 can be written as, 32 factorial can be written as 1 into 2 into 3 into 4 till 32. Now what I am doing, I am making a group of 5 digits starting from 1. 5 consecutive digits I am taking starting from 1. So the brackets I am giving, each group is given in the bracket. There 1 into 2 into 3 into 5, then start with 6, 7, 8, 9, 10 and this thing goes on. So we can easily see that there will be 6 such brackets in which there will be 5 consecutive digits. Clear? And the last bracket or the last group, it consists of only 2 elements. The question is factorial 32 is given. If the question would have been factorial 33, then in the last bracket, 3 digits will come. Like 31 into 32 into 33. Okay? Now what? I have to find out the first non-zero digit when this whole thing is multiplied. But again, practically it is not possible for us to multiply. So now let us observe the first group. The elements or the digits in the first group is 1 into 2 into 3 into 4 into 5, which actually gives us 12 into 10 into 1. Now why I have written in this way? My main motto is I have kept the 0 aside. Since 12 into 10 into 1, I have kept that 0 aside. Why? Because I simply want to find out the last digit of factorial 5 when 0 is kept aside. That is, if you see, what is 1 into 2 into 3 into 4 into 5? That gives us 120. And if it is 120 and keep that 0 aside, if I remove this 0, what is the last digit that you are getting? Which is nothing but 2. And which is eventually the first non-zero digit. Getting my point? That is the reason why I have kept this 0 aside. So the first non-zero digit will come from this bracket when 2 is multiplied with 1. Because the first non-zero digit, as we can see, it is 120. So it will be 2. And this 2 is coming from where? When this 2 is multiplied with 1. Isn't it so? Because when 12 is multiplied with 1, you are getting 12. So what is the last digit? The last digit is 2. How you got? You got it when 2 is multiplied with 1. Is it clear? So, in the first bracket we are getting our first non-zero digit will come when 2 is multiplied with 1. Let us consider the second bracket. 6 into 7 into 8 into 9 into 10, which gives us 12 into 10 into 252. Again, the same logic. I have kept this 0 aside. Why? To find out what is the last digit when 12 is multiplied with 252, which eventually gives us first non-zero digit of the numbers when 6 multiplied with 7, multiplied with 8, multiplied with 9 and multiplied with 10. That's it. Is it clear? So the first non-zero digit will come when 2 is multiplied with 2. Am I correct or not? When 2 is multiplied with 2, forget about that 0. When 2 is multiplied with 2, that is the last term when 12 is multiplied with 252, and which eventually is the first non-zero digit of these digits when multiplied together. So the first non-zero digit will come from the second bracket is when 2 is multiplied with 2. Is it clear? Let us consider the third bracket. In this case, we are getting 11 into 12 till 15 gives us 12 into 10 into 3003. Again, multiplied with 10. Forget about that. That is, I am keeping that 0 aside. So the first non-zero digit, or you can say the last digit of this number which we got after multiplication will come when 2 is multiplied with 3. Is it clear to all of you? So the first non-zero digit will come from 2 into 3. And that is the beauty of number theory. Here you don't have to go for actual calculation. Simply by using your common sense, you can understand what is actually happening and you can identify the pattern. Okay, let us just move for the sum and consider the last bracket, which is 26 into 27 till 30. That gives us again 12 into 10 into 142506. So no need to explain right now. The first non-zero digit will come from 2 into 6 when this 2 is multiplied with this 6. Clear? And the last bracket, which consists of only 2 digits, 31 and 32, the first non-zero digit will come from this bracket when 1 is multiplied with 2. That is 1 into 2, which gives us factorial 2. Is it clear? Now listen one thing very carefully. Again, common sense. Suppose we are having in one bracket 77 into 35 and in another bracket I am saying say 49 into 86. Okay. Now I want to find out the last digit when you multiply all those digits. Clear? So the shortcut way of doing that is you have to find out what is the last digit coming from this number, which is in this case will be 5. And when you multiply the second bracket, the last digit that is going to come is basically 4. So when you multiply this with this, you are going to get the last digit as 0. Isn't it so? Because when 5 is multiplied with 4, you are getting 20. So the last digit of this whole number will give us what? 0. Is it clear? Same thing here. To find out what is the last non-zero digit of factorial 32, we will simply find out what is the first non-zero digit coming from 2 into 1, then 2 into 2, then 2 into 3. This goes on till 2 into 6, and at last it will be factorial 2. Is it clear? So I am writing it here in this way. So the first non-zero digit will come from this product, which is same as your 2 to the power 6 into factorial 6 into factorial 2. So what will be the first non-zero digit? 2 to the power 6 gives us 64, factorial 6 gives us 720, and factorial 2 gives us 2. No need to multiply the complete thing. Simply apply the logic. What will be the last digit, which is eventually the first non-zero digit? Is when 2 is multiplied with 2, that gives us 4. And when this 4 is multiplied with this 4, the last digit is 6. Yes or no? Therefore, the first non-zero digit of factorial 32 is 6. Now the question comes, sir, do I have to do all those things everywhere when this factorial thing is given? Answer is no. Because this will be rather a long method of solving. This example I have chosen and I have explained it because to make you understand how the actual logic is coming. Now we will go how to formulate a formula so that you can use it to find the last digit of any factorial. Back to the computer screen. The first non-zero digit, I will denote it by U. The first non-zero digit, I will denote it by U. That means, if I say U of factorial 32, it means we are talking about finding out the first non-zero digit in factorial 32. That is the notation. So in our problem, we got that U32 factorial is basically U of 2 to the power 6. Because we have calculated the last non-zero digit from 2 to the power 6. Then we have calculated the first non-zero digit from factorial 6. And then we have calculated from factorial 2. But the question is, sir, until and unless I expand the factorial which is given, how do we know that how many number of brackets are actually forming? Because what is 6? If you observe in the previous slide, you will see that actually your 6 is the number of brackets that we have formed. So for that, I am giving you a formula. Now, you have understood the logic. Now you can use the formula to find out the first non-zero digit of any factorial. And that logic is U in factorial is U2 to the power Q into U factorial Q and U factorial R. I will explain what is your Q and R is all about. Here, Q is basically the quotient when 32 is divided by 5. What is the factorial given to us to find out the last non-zero digit? It is 32. So you simply divide that 32 by 5. So you are getting remainder is 2 and your quotient is 6. So now you have understood what is your Q and what is your R. Q is the quotient, R is the remainder. Whatever factorial is given to you, that is your n. So divide that n by 5. Sir, it is every time with 5? Yes. Because we have made that bracket of 5 digits taken at a time. That is why you have to divide it by 5 every time, whatever factorial is given to you. So simply divide it by 5. You got the quotient, you got the remainder, and simply write in this formula to get the first non-zero digit of that factorial. Is it clear? In this case, you see, when 32 is divided by 5, we are getting quotient as 6 and remainder as 2. So I have written u of factorial 32 as u of 2 to the power 6. Why? Because 6 is the quotient, factorial 6, and the remainder is 2. So I have given factorial 2. That's it. Now I will calculate what is the last digit of 2 to the power 6. In our case, 2 to the power 6 is basically 64. Factorial 6 is 720. And factorial 2 is 2. So the first non-zero digit from 64 is 4. The first non-zero digit from 720 is 2. And the first non-zero digit of 2 is 2 only. So when these three are multiplied, we are getting 16. Therefore, the first non-zero digit in factorial 32 will be nothing but 6 only. Have you understood this? Absolutely clear? Let me take one example. See this question. The question is, find the first non-zero digit of 137 factorial. What to do? First step, divide 137 by 5. So what we are getting? So quotient is 27 and remainder is 2. So according to our formula, what was the formula? Un factorial equals to u 2 to the power q factorial q factorial r. So in our case, we will write 2 to the power 27 factorial and factorial 2. Is it clear? Now, two big questions will come. The first question, see this computer screen. 2 to the power 27. Sir, it is not possible for us to calculate this. Yes, it is true. Not possible for us. That is why I taught you that what will be 2 to the power n whole to the power n? What will be the last digit of this? This I will apply in this problem. See, I am simply calculating 2 to the power 27. Again, I have to find out what is u 2 to the power 27. I have to find out the first non-zero digit of 2 to the power 27. So what I am writing here is 2 to the power 27 can be written as 2 to the power 10 whole square into 2 to the power 7. Am I correct or not? It gives us 2 to the power 20 into 2 to the power 7, which gives us 2 to the power 27. 2 to the power 10 is 1024 and its power is 2. We all know that 1024, when the power is even, the last two digits will be always 76. Can you remember? So this is basically u of 76 when multiplied with 2 to the power 7, which is 128. So what will be the first non-zero digit here? It is when 8 is multiplied with 6, that gives us 48. That is only 8. So 8 will be the first non-zero digit of 2 to the power 27. Is it clear to all of you? So your u137 factorial now comes to 8 into the first non-zero digit of 27 factorial into factorial 2 is 2. So this is basically 8 the last non-zero digit of 2 is basically 2. 27 factorial. So now 8 2s are 16. So what will be the last digit? The last non-zero digit will be nothing but 6 here. So write down only 6. No need to write down 16 because we don't know the 10. We don't want the 10th place of that number. So that is why simply consider the unit digit number, right? And now the big questions are how to find out factorial of 27. What is the first non-zero digit of factorial 27? Apply the same method. 27 you simply divide it by 5. So it gives us. So this is the quotient, this is the remainder. So how I will write 6 into 2 to the power 5 factorial 5 and factorial 2. Is it clear? I have used the same formula here also because it is factorial 27 and we have to find out the first non-zero digit of that. 2 to the power 5 gives us 32. This is 120 and this is 2. So the last non-zero digit of U32 is 2. Of 120 is 2 again. And for this 2, it is 2 again. So what will be the first non-zero digit of factorial 137? It will be 6 2s are 12, 12 2s are 24, 24 2s are 48. So the last digit will be nothing but 8. Is this problem clear? Fantastic way. You see, you may say, sir, it is taking a long time. No. Since I am making you understand, that is why it is taking such time. But when you will practice, you will see these problems can be solved within 1 minute. Right? So let us again to the computer screen. So our answer is 8. Let me take another example. In this question, we have to find out the first non-zero digit of factorial 100 into factorial 165. So we have to find out what is u of 100 factorial into 165 factorial, correct? Which can also be written as u 100 factorial into u 165 factorial. Now this is all same. Because of finding out the first non-zero digit of factorial 100 into factorial 165 is same as finding out the first non-zero digit of factorial 100 multiplied with the first non-zero digit of the factorial 165. And from there we can find out the first non-zero digit of this final product. So 100 divided by 5 gives us remainder is 0, and when 165 is divided by 5 we are getting the quotient is 33 and remainder is 0. Therefore we can write this as multiplied with Is it clear? I have simply used the formula here, nothing else. Factorial 0 is 1, this is 1, so it will go off. 2 to the power 20 can be written as 2 to the power 10 whole square. 2 to the power 10 is 1024, and when the power is even, the last two digits is 76. Two to the power 33 can be written as 2 to the power 10 whole 3 into 2 cube. This is 1024 whole cube into 2 cube, right? The last two digits will be 24 as the power is odd into 8. Clear? So I'm writing it here. For factorial, for 2 to the power 33, I'm writing it as 24 into 8. Factorial 20 I will calculate. Factorial 33 I will calculate. From this, the last digit that we are getting is 6. From this one, the last digit that we are getting is 8 4s are 32, that is 2. We have to calculate factorial 20 and the first non-zero digit of factorial 33. So the last non-zero digit that will come from 6 into 2 is 12. So that is 2. So for 20 factorial, again I am dividing by 5. And for 33 factorial, divide by 5. Remainder is 3. Therefore, we can write this thing as and for factorial 33, we are getting 2 to the power 6, factorial 6 into factorial 3. So 2 to the power 4 is the first non-zero digit of 2 to the power 4 will give us 6. Factorial 4 is 24, so the first non-zero digit is 4. Factorial 0 is again 1. 2 to the power 6 gives us 64. So the first non-zero digit will be 4 again. Factorial 6 is 720. And factorial 3 is 6. So from here we are getting 6 2s are 12. 12 4s are 48. 48 means the last non-zero digit will be, the first non-zero digit will be 8 and multiplied with 4, that gives us 32. So the first non-zero digit from this part is coming to 2. Am I correct? The first non-zero digit from 720 is coming to 2 again. And the first non-zero digit is only 6. So 6 is there. Now if we multiply this, we are getting 24. So the first non-zero digit will be nothing but 4 only. Is this problem clear to everyone? See, it's pretty simple. Simply use the formula and find out what will be the last digit of that expression, because I have already separated 0. So whatever last digit you are getting in multiplication is basically the first non-zero digit of that expression, right? Because I have ignored that 0. Can you remember? I have multiplied with 10. So what I have done? I have separated 0. So actually we are finding out the last digit of that expression, which is eventually the first non-zero digit of that expression. Okay, so our answer in this case is 4. I hope this problem is clear to all of you. Let us move for the next problem. The question is, find the first non-zero digit of factorial 100 plus factorial 165. Now one should not do this problem by solving the both. That is why I told you in number theory, maximum case you have to use your common sense. And that common sense, ultimately it will generate a result which would have been a big one if you go for actual mathematical operation. And that is the beauty of number theory. So in this question, I will not find out the first non-zero digit of factorial 100 as well as factorial 165. Because simply apply your common sense, factorial 165 will have more zeros at last, and then factorial 100. So the first non-zero digit of this expression, factorial 100 plus factorial 165, will be the first non-zero digit of factorial 100 only. So if I simply find out what is the first non-zero digit of factorial 100, that will eventually gives us the result, what will be the first non-zero digit when factorial 100 and factorial 165 are added together. Why? Because 165 will have more ciphers or more zeros at last. So the first non-zero digit will not come from factorial 165 when added with factorial 100. The first non-zero digit will come from factorial 100 itself. Okay? So for factorial 100, I will divide it by 5. So there is no remainder. So this is basically 2 to the power 20 into factorial 20 into the first non-zero digit of factorial 0. 2 to the power 20 again, which can be written as 2 to the power 10 whole square, which is 1024 whole square. So the last two digits will be 76. Again, I'm telling you, in this case, only 6 will actually help us to solve this problem. But okay, we have already learned the last two digits of 1024 when the power is even. So that is why I'm taking it, because it will be needed in right after this section. When we will move for the next section after this part, there we will need the last two digits. That is why I'm doing it right here. So the last two digits will be 76. So the first non-zero digit will be 6 in this case. Factorial 20, I will do it right now, and this is 1. 20, again divide by 5. So this can be written as 2 to the power 4. Factorial 4. Factorial 0. So this is basically 16, 24, 1. So 6, the first non-zero digit will be 6 in U16, and in U24 the first non-zero digit is 4. So the thing is coming to 6, 6, 36. So the first non-zero digit when we multiply 6 with 6 is 36. That means it's only 6. And when this 6 is multiplied with 4, the first non-zero digit will give us, actually it is coming to 24, though the first non-zero digit will be 4 only, right? Therefore, our answer in this problem is 4. That is the first non-zero digit of factorial 100 plus factorial 165 is 4. Have you understood this problem? So, in the number theory, you will be always alert while doing sums. You should be very alert, because otherwise what will happen, you have to go for this long calculation. One who is not applying his common sense, what he will do? He will first find out what is the first non-zero digit of factorial 100. Then he will find out what is the first non-zero digit of factorial 165. Then he will see that 165 will have more ciphers at end. Therefore, he will come to our same logic, but after doing so much of work. To save time, apply common sense. Now let us move for the next problem. You see in this case what they have said? Find the first non-zero digit of factorial 100, factorial 110, factorial 120, factorial 130. Now think about it. Will I have to calculate every factorial for finding out the first non-zero digit? No. Why? Because factorial 110 will have more ciphers at end than factorial 100. Same thing with factorial 120 and factorial 130. So the first non-zero digit that is going to come is from factorial 100 only. And just now we have done that the first non-zero digit of factorial 100 is basically your 4. So in this case also, this whole answer, no need to calculate. You will straight away say the first non-zero digit of this expression is nothing but 4. Is it clear to all of you? Have you understood how I am applying my common sense? You too have to apply that. Right? So now we will find out the first two non-zero digit in factorial n. We know the logic as well as we know the formula that has been developed from that logic, how to find out the first non-zero digit of any factorial. Now we will learn how to find out the first two non-zero digit of a factorial given to us, say factorial n. Okay? Okay, back to the computer screen. Now, we will describe this thing with an example. Now let us take the example, find the first two non-zero digits of factorial 32. The same example I am taking here. So what we have done, 32 factorial I have written in this way. Then we made a group of 5 digits taken at a time. In this case also we have done it. Now let us consider the first group, that is 1 into 2 into 3 into 4 into 5. We are getting what? 12 into 10 into 1. Now while finding the first non-zero digit in factorial n, we have considered only one digit of this 12. Can you remember? I have said that you simply multiply 2 with 1 to get the first non-zero digit in factorial n. Because in that case we need only one non-zero digit. But in this case we need 2 non-zero digits. Therefore, in this case, we have to consider this 12 as a whole. When this 12 is multiplied with 1, we are going to get the last 2 digits of the number 1 into 2 into 3 into 4 into 5, excluding the 0. Because I have already separated the 0 by saying that it is multiplied with 10. Actually, it is coming to 120. So I am simply removing this 0. I am keeping this aside. And to get the first two non-zero digit that will eventually come from 12 into 1, that is clear to us. Therefore, the first two non-zero digit will come from 12 into 1. Same thing with the second bracket. 6 into 7 into 8 into 9 into 10. The first two non-zero digit will come when this 12 is multiplied with this 2. So we are writing it here that first two non-zero digit will be 12 into 2. Is it clear? Now again take the third bracket. Now I hope you have understood the first two non-zero digit will come from 12 into 3. And the last one is 12 into 10 into 1, 4, 2, 5, 0, 6. So the first two non-zero digit will come from 12 into 6. Same thing here. In the first non-zero digit, we have multiplied with 2. 2 into 1 for the first bracket. 2 into 2 for the second bracket. 2 into 6 from the sixth bracket. Same thing here. But I am in this case considering 12 as a whole. I am not taking only 2 because I don't need the first non-zero digit. I want the first two non-zero digits. That is why I am considering 12 here. Clear? and the last bracket is given to us as 31 into 32. Now if you can remember, in first non-zero digit we have only considered 1 into 2 because the first non-zero digit will come from 1 into 2 itself. That was factorial 2. But in this case we have to consider both the numbers because we need 2 non-zero digits. Therefore here the 2 non-zero digits will come from 31 into 32. We cannot eliminate any digit from here. Have you understood this, right? Therefore, the first 2 non-zero digit will come from the product this one, which is same as, you see, when we are finding out the first non-zero digit, we used to write, the notation was u. Okay, so if I write u factorial 32, you will understand that we are actually talking about the first non-zero digit in factorial 32, isn't it so? But in case of 2 non-zero digit, the notation will be t. If I give you t factorial 32, you will understand that I am talking about to find out the 2 non-zero digit of the number factorial 32. Therefore, this whole number can be written in this way, that the 2 non-zero digit of factorial 32 is same as finding out the 2 non-zero digits of 12 to the power 6, same for factorial 6, and then for 32 into 31. Is it clear? So what will be the answer? Now look it carefully. In this case, when the last 2 digits of, the 2 non-zero digit is considered for 12 to the power 6. So 12 to the power 6 can be actually written as, am I correct? It is 4 to the power 6 into 3 to the power 6. 4 to the power 6 can be written as 4 to the power 5 into 4, and 3 to the power 6 can be written as 3 to the power 4 into 3 square. Am I correct? Now 4 to the power 5 is basically 1024 into 4 into 3 to the power 4 is 81, and this is 9. So now when 1024 is multiplied with 4, the 2 non-zero digit will be nothing but, when 24 is multiplied with 4 gives us 96, right? And when 81 is multiplied with 9, the 2 non-zero digit at last will be 9, 9 8s are 72, so only 29 will come here, right? Now from 96 and 29, what will be the last 2 digits? We have already learned this. 9 6 are 54, keep 5 in hand, then cross multiply, 9 9s are 81, 6 2s are 12, only 2 we will write. So it is coming to 84. Therefore, t 12 to the power 6, that is the 2 non-zero digit at the end, will be nothing but 84. Am I correct or not? Have you understood this or not? Okay, what about factorial 6? Factorial 6 is 720. So what is the 2 non-zero digit in 720? It is 72. So t 12 to the power 6 is basically, I am writing it here, it is 84, and for factorial 6 the last, the 2 non-zero digit will be 72, and 32 into 31, again we can find out 32 into 31, what will be the last 2 digits? It's 92, right? So what will be the last non-zero digit? 2 non-zero digits that will come from this. it is 84 into 72. That gives us from this we are getting 48 into 92. So it's coming to 06. That's it. So the first two non-zero digit in this product is going to give us 06. Is it clear to everyone or not? Is it clear to everyone or not? So that's the answer. So now let us try to formulate the formula for finding out the last two non-zero digit of any factorial. See this one. T of factorial n is T of 12 to the power q, T into q factorial into T n minus 1, n minus 2, 2 R terms. What is R? R was the remainder. What is Q? Q is the quotient. So how to get that? Simply you divide 32 by 5. So you are having remainder is 2. Therefore your quotient is 6 and remainder is 2. So how you will write? I am writing it again. You will understand that. T of factorial 32 becomes T of 12 to the power 6 factorial 6 into T, remainder is 2. So how you will write it? You will write, actually you have to find out factorial 32. So you will write 32 minus 1 gives us 31, and I will only write these two terms. Isn't it so? Why? Because the remainder is 2. That is why I have written 2 terms. That's it. So this is how we find out the two non-zero digits from any factorial given to us. Is it clear to everyone? Okay, so now let me give you a problem for your homework. This will be again your homework. You have to find out what is the first non-zero digits of 137 factorial. Please do comment me in the comment box what is its answer. What is the first two non-zero digits in 137 factorial. Is it clear? So that's all about this session. We will be meeting very soon in my second session of permutation and combination. Till then, stay tuned to us, subscribe, share, and definitely comment me whatever homework I have given you. Please do comment me. Then only I will understand that you people are actually learning. Otherwise, this effort will all go to vain. Is it clear? So till then, stay tuned to us. Thank you so much.